In this video, I will explain you what is the EMF induced in a coil which is rotating in a magnetic field. Now, when a coil is rotating in a magnetic field, we know that, see, it is rotating in the same magnetic field and even the area of the coil is also not changing. But see, this is the vector A, area. Now the area, the vector A, direction of vector A keeps on changing during the rotation. So the angle A makes with magnetic field will also change with rotation. Now what is the equation for magnetic flux? BA cos theta. Out of that, B is constant, A is constant, cos theta is changing here. Now BA cos theta is for one coil. Now with N coil, it will be NBA cos theta. So with flux linked with one coil, now flux linked with N coil. This is the total flux linkage. Now we need to get the value of EMF. So we will substitute in this equation. See, out of this equation, minus is just representing the direction. That is only information minus gives. So you can neglect E. Consider that we are only deriving the equation for magnitude of EMF induced. So that is equal to d phi by dt. And flux is equal to BA cos theta. So that will be d by dt of BA cos theta. NBA cos theta, with N coil it is, right? NBA cos theta. Now out of that, number of turns B and A, these are the constant here, so I can take outside because magnetic field doesn't change, area of the coil doesn't change, number of the turns doesn't change with rotation, only cos theta or theta is changing. So NBA I am taking outside, d by dt. Now this is rotational velocity, omega. We know that distance is equal to velocity into time. So similarly, angular distance, theta is equal to angular velocity into time. So theta can be written as cos of omega t. Now what is differential of cos theta? That will be sin theta. So NBA, I'll keep the negative sign here because the negative sign will anyway get cancelled in the next part, negative. So differential of cos omega t is minus sin omega t. So that minus and minus will cancel here. Minus sin omega t into omega. So this will be NBA omega sin omega t. This is the EMF induced. And out of that we know that omega is constant, A is constant, B is constant, and number of turns is constant. So all these, as it is constant, I can say that this is the maximum value of EMF. That will happen when sin omega t is 1. Maximum value of sin and cos function is 1. So what is the maximum value of this function? That will happen when this value is equal to 1. At 1, this will be maximum value. So E max is equal to NBA omega. So E max into sin omega t. E is equal to. This is very important. Now if I am connecting this with a resistor having resistance of R, then I induced is equal to, we know that voltage divided by resistance is I induced, that will be E max sin omega t is the voltage, right, divided by R. So E max is a maximum quantity of E, which is a constant, R is again constant. So E max divided by R can be written as I max sin omega t. So I is equal to I max sin omega t and E is equal to E max sin omega t. Now this will be an alternating current. Why, you know? See here the current coming is not constant. With respect to theta, the value of current changes. Let's say omega t is theta, right? When the angle is 0, angle is 0 means area makes, this is magnetic field, right? Area makes 0 angle with, this is area. So area makes 0 angle with magnetic field. At this value, E and, so angle theta, E and I. So when theta is equal to 0, sine 0 0, here also sine 0 0, so 0 into Emax and 0 into Imax, both are 0, which means magnetic field in this way and my area is in this way. Here maximum magnetic flux linkage is there, but the change is less. That is the reason we got 0. Now when theta is 90, sin 90 is 1, here also sin 90 is 1. So theta is equal to 90, this will be Emax and this will be Imax. Now theta is equal to 180, again sin 180 and sin 180 is 0, so both will be 0. Next one is very important, 270. When theta is 270, sin 270 is minus 1, here also minus 1. So Emax will be minus Emax and Imax will be minus Imax. So direction changes. Now see, I am going to plot a graph here. This is very important. At 0, this is the angle 0. At 0, current and EMF are 0. So this is the circuit for EMF first. So EMF start increasing from 0 to a maximum value at 90. So this is 90. At 180 that comes to 0. Then at 270 Emax is going to negative direction. So that is minus Emax. Then again on 360, at 360 also this will be 0. You can substitute sin n pi is equal to 0. So this is 0 pi, 1 pi, at 2 pi also it is 0. So this is Vmax. This one is also Vmax. And voltage is alternating, increases to maximum, then 0, then increases opposite direction, then 0. So this is voltage, variation of voltage with angle theta. So with one complete revolution, we will get a variation in this way. Now what will be the variation of current? We know that Imax will be less than Vmax because Imax is equal to Emax divided by R. So normally resistance value will be greater than 1. So when we are dividing with a number greater than 1, the total value will decrease. So Imax will be little bit less. So if I am plotting on the same graph, it is also varying the same way but a bit less. This is how Imax will vary. Sorry, I will vary. So this is variation of current, this is variation of voltage. Both are in phase. Phase means, see, the variation of current and voltage is the same. So this is basically AC. Now in AC you can see voltage in this way. Even current also, this will be the graph. In one complete cycle, it will have 2 maximum value and 0, 4, 0, 3 0 values. At 0, 180 and 360. This is 90 and 270. Okay, thank you.